In this example, we're going to take a look at the minimization problem from section 7.5 in the book. So now we're dealing with M&D Chemical Company, and they produce 2 chemicals that are sold as raw materials to other companies. We are told that in each production period, they produce a combination of at least 350 gallons, but additionally, they need to produce 125 gallons of product A, and they are dealing with a constraint of only 600 hours of processing time for both products. We're told that product A requires 2 hours per gallon to process and product B requires 1 hour per gallon. So again, this is a cost minimization problem. Each of these products, product A and B, have a production cost associated with them, and we want to know what's the best mix of A and B to minimize the cost. And then figure out what is that minimum cost. So our first question is, what are we making? We know that we're making product A and product B. The second question that we ask is, how many of each are we making? This again is going to be our solution. We want to know our product mix that's going to minimize our cost. So these cells we highlight in yellow, that's our solution. Then from there, like we said, we have production costs associated with each product. So these are the costs that are going to indicate the elements that actually go into satisfying the objective function in using solver. Remember, our objective again is to minimize cost. So we are told that product A has a production cost of $2 associated with it, and B has a cost of $3. Then remember, our goal is to find that minimum cost for our total product mix. So this cell we'll highlight in green. And as always, we are dealing with constraints. With cost minimization problems, you need constraints that instruct you how many we have to make. Obviously, we would have a minimum cost of 0 if we didn't make any, but we have demands. If we didn't make anything, we wouldn't have a company. So the constraints are for the quantity we need to make. And management tells us again that we need to make a minimum of 350 gallons for product A and B. So our first constraint is going to be for product A and B, minimum. Our second constraint is we have a customer order. We have another product A minimum. And then finally, we have a production time constraint. We only have 600 hours in which to make our product mix. So here when we're entering these, we're counting the items toward the maximum produced. So in the product A and B minimum, we're producing 1 of each. In the product A minimum, so our customer order, we're producing 1A and 0 of product B. Then in our production time constraint, we are told that it takes 2 hours to make a gallon of product A and 1 hour to make a gallon of product B. Center these so they're easier to see. Our next step then is to go ahead and add in our less than equal to, plus than equal to signs to go along with our constraints. So we know that product A and B minimum has to be, it has to be a minimum of 350. So we need to produce greater than or equal to 350. So moving down, we know that for our customer, we need to produce greater than or equal to 125 gallons. Then finally, our production time constraint, we only have 600 hours. So we need to use less than or equal to 600. And then again, our outputs here we'll highlight in blue to see how many of each we're using. So our next step before we can do the solver is to add sum product operations. So go back up to our minimum cost, our green cell, and it equals sum product. And we want the solution set, and we want to lock that in, comma, the cells to the left. And again for the blue, so equals sum product, the solution set, that's an absolute cell reference, comma, the cells to the left. You can just copy that down, and we can see that we don't have any inputs yet, so our outputs are still 0. Now we're ready to use the solver. So you go up and you put your cursor on the green cell, the minimum cost, or this is going to be our objective value. Then go to the Data tab and over to Solver. Our solver window will pop up, and we can see that our set objective is this cell D5, this green cell. But now set objective to a minimum by changing the variable cells, our yellow ones there, and it's subject to constraints. So we need to add in constraints. This time we have a few to add in. And these first two, we add the cell reference, and then they are greater than or equal to the constraints. So we'll add those in, and then we need to go back and add our production time constraint. So add. Now we'll do our production time constraint. Cell reference less than or equal to constraint 600, and we click OK. Now when our solver window pops back up, we can see we have two different lines of constraints. We have our greater than equal to and our less than equal to constraints. So then make sure that your make unconstrained variables non-negative box is checked. That just means we want to keep everything on the positive side. And you need to select your Simplex LP, your linear programming method. Then go ahead and click Solve. We would like an answer report. So click on Answer and then click OK. And then we can see that just popped up another sheet in our workbook for us. So now our solution, as we can see here, is that we are going to produce 250 gallons of product A, 100 gallons of product B, and our minimum cost is 800. Now if we go and look at our constraints, we can see that we are only producing 350 gallons of A and B together. We are producing 250 gallons of product A for our customer, so our minimum there was 125. So we have 125 gallons of surplus here. Surplus is just the opposite of slack. We have extra left over now. And production time, we are using all 600 hours that we have. So if we go ahead and we look at our answer report real quick, we can see again that we're making 250 gallons of A, 100 gallons of B. If you go down to the constraints, we can see that our product A and B minimum was 350, had a slack of 0, therefore it's binding. Production time was 600 hours. Again, that's binding. We have 0 left over. And then production A minimum. Remember that minimum was 125, but we produced 250, so we have a slack or a surplus of 125. That is not a binding constraint. So again, in this example, we just used linear programming in Excel to solve a cost minimization problem.